Hello and welcome to another EdLitera video. In this one, we will cover automatic text summarization. This video is actually based on an article we have on our blog, so if you prefer reading or watching videos, click on the link in the description below. For those of you that are still with me, we're going to cover automatic text summarization by first explaining what automatic text summarization is and what are the different automatic text summarization techniques. Then I'll show you how to implement automatic text summarization in just a few lines of code. So I'll show you a simple implementation, and we will finish the video by going over a more complex implementation of automatic text summarization that uses the Pegasus transformer model. So let's get started. Automatic text summarization is the process of taking in a larger text document and condensing it into a smaller text document. That smaller text document is called a summary, and it contains all of the important information that was stored in the original text document. Performing this task, so summarizing text, is usually a very time-consuming process, so it's very inefficient to do it manually. Therefore, it's a much better idea to perform automatic text summarization. Automatic text summarization allows us to use different algorithms and machine learning models to perform the task of text summarization for us. Many people overlook this field, so automatic text summarization, because it is not as popular to the general public as some other fields, such as, for example, creating chatbots or creating models that can translate text from one language to another language. This, however, does not mean that there's not much a company can gain from creating and using an automatic text summarization pipeline. These pipelines allow companies to spend less time analyzing data because they have less data to analyze, and therefore they can spend that time in a more productive way. A typical example can be found in companies that sell products. So a company that sells products will usually collect reviews about their products. Those reviews can be pretty long, so if you have an automatic text summarization pipeline, you can run that review through the pipeline and you will get a summary that's 1 or 2 or 3, however long you want, sentences long, which will allow you to analyze only that summary instead of analyzing the whole review itself. Basically, there are two types of automatic text summarization models. Those are extractive summarization models and abstractive summarization models. Extractive summarization algorithms and models perform summarization by taking a look at the original text document and then extracting particular sentences from it. So the summary itself is actually built from the sentences that were in the original text document. On the other hand, abstractive summarization is performed similar to how we humans summarize text. So the sentences that are used and the sentences that you can find that the model created in an abstractive summary are usually not present in the original text itself. So let's start with the simpler of two techniques, which is extractive text summarization. TextRank is a graph-based ranking algorithm inspired by Google's PageRank algorithm. It's an unsupervised extractive summarization method. This means that our summary is going to include data from our original text data. To be more specific, even though TextRank is actually a fairly complicated algorithm, and you can learn how it works in detail by reading our article, which you can get to by clicking on the link in the description below. On a high level, we can say that summaries are created by selecting the top n ranked text chunks. Now, what does this actually mean? Well, if I have, let's say, an article of 25 sentences, what TextRank is going to do is it's going to take a look at all of those 25 sentences and it's going to assign them a rank by how important they are to my article. Once we have all sentences with their respective ranks stored, then we can select the top n ranked text chunks or sentences to create our summary. For example, if I have a 25 sentence article, I can select that I want the top 3 sentences to form my summary. So this is an extractive summarization method because the sentences that I will use to form my summary are sentences from the original text itself. To implement our TextRank, we're just going to use Spacy. So Spacy is an open source, so a free library for industrial strength NLP. If you don't have Spacy installed, if you haven't used it before, you can install it using just pip install spaCy, and of course, if you don't have TextRank installed, you can install it using pip install pytextrank. Now, if you don't know how to work with spaCy, unfortunately, you're going to have to learn more about it. However, this tutorial by itself should allow you to perform text summarization as long as you have stuff installed without you even actually understanding how spaCy works in detail, because we'll go over some basics right now. So because I have everything installed, I can actually just import the necessary libraries, and I can go ahead and define a typical spaCy pipeline. So spaCy generally works by us creating pipelines. A pipeline is just a model. So as you can see, I'm using load from spaCy to load in a model. I've already pre-downloaded this model. You can download models by running the following code in Python. So you can just download particular models. This is a large model. If I wanted to download a small model, I would replace LG with SM. But for the purposes of this demonstration, we're going to use a large model. And once I've loaded in that large model, I'm going to store it inside of a variable. People usually store spaCy models inside of a variable that's called NLP. Now that I've stored the model inside of that variable, I can go ahead and add TextRank to my pipeline. So to add something to my model, I'm just going to use the addPipe method, and I'm just going to say TextRank. And this adds the TextRank algorithm to my spaCy pipeline. And this is all I need to do to actually perform extractive summarization. Once I do this, I now have TextRank included into my model, and I can go ahead and demonstrate how it works. To demonstrate how it works, we're just going to take some example text and store it inside of the example text variable. So this is how it actually looks like. So it's just some text about deep learning from Wikipedia that explains what deep learning actually is. As you can see, there's a fair amount of text here. It's not too long, but it's long enough for us to demonstrate how a summary would look like. So if I go ahead and run my spaCy pipeline that contains the TextRank algorithm over my example text, I just need to define the variable in which I stored my spaCy pipeline and run it over my example text. I can then store the result inside of the doc variable, and this is all I needed to do. If I want to access the summary right now, what I'm going to do is I'm going to iterate over this here generator object. Now this object actually tells us which are the top ranked phrases. So when I say limit sentences to 2, it's actually going to take the top 2 ranked sentences. If I say limit sentences to 3, it's going to take the top 3 ranked sentences. So this limit sentences is actually the n from our top n ranked sentences. So for example, let's leave it at our top 2 ranked sentences and print the result. As you can see, we still have quite a lot of text. That's unfortunately the result of us having one very big sentence. So this is all one sentence, and this is another sentence. So if I wanted, I could limit this to just one sentence, and then I will get a result that looks like this, because this seems to be the top ranked sentence in our whole article. Now, there are other things that you can modify here. For example, you can add a parameter that's called limit phrases, and let's say that it's 2, and run, and you're going to get a result that's a little bit different. However, to understand how the limit phrases argument interacts with our summary, you need to take a look at our article, because it explains how phrases, or how does actually TextRank create phrases, and how does it rank phrases by itself. Let's leave it at just limit sentences for now. And we have our result. Now, if you are interested, you can take a look at different phrases and their ranks. So I can just say for phrase in our phrases, give me that particular phrase and give me the rank of that particular phrase. So if I go ahead and print out the top 10 ranked phrases, I'm going to get the rank of the phrase, and I'm going to get the phrase itself. So one thing you can notice here, even if you don't read our article, is that the top phrase, deep neural networks and neural networks, and the top two phrases are the phrases that are probably going to appear in our top ranked sentences. So for example, in this sentence, we have deep neural networks and we have neural networks appearing multiple times. So because that top ranked phrase appears multiple times in our in this sentence right here, it becomes our top ranked sentence. And this is how actually TextRank works if you take a look at it on a high level. Now that we've explained how TextRank works, how our extractive summarization algorithm of choice works, let's go ahead and take a look at our abstractive algorithm of choice, Pegasus. Now that we've gone through extractive summarization and now that we've explained the TextRank algorithm, we can go ahead and talk about Pegasus. Pegasus is a state-of-the-art transformer model for creating abstractive summaries. The model itself is pretty complicated and the way it functions is pretty complicated. So if you want to take a look at the details, go ahead and read our article. However, just to keep it on a high level, we're just going to say that it's a particularly trained transformer model. So most transformer models are pre-trained on general NLP tasks, but Pegasus as a transformer model is pre-trained on a task that is intentionally similar to summarization. So actually what happens is relatively simple when we talk about it on a high level. We take some input document that has a particular number of sentences, let's say 10 sentences, and then we hide, for example, every second sentence. Let's say that we hide the second, the fourth, and the sixth sentence from those 10 sentences. Now, what the model tries to do, it tries to generate those sentences and combines them into one output sequence, which means it tries to guess what is the second sentence, what is the fourth sentence, and what is the sixth sentence. Because the model is not perfect, it can't guess the sentence exactly. However, it gets the general idea that the sentence is trying to convey. So it creates an abstractive summary, a summary that's made out of sentences that are not present in the original document. Let's demonstrate how we actually create a Pegasus model. So we are going to use the Transformers library to do that. If you don't have the Transformers library, you can just pip install it. And we're going to import Pegasus for conditional generation from that Transformers library, and we're going to import a tokenizer. Now, once we get to the tokenizer and the model, I'm going to go a little bit more in depth on them. However, once we have this imported, this is all we need. Now we just need to pick a model. Now, you might ask yourself, why are we picking a model if we've already picked Pegasus? Well, we're going to use a pre-trained model. So we're going to avoid training a model again from zero, and we're just going to use an already trained Pegasus model. You can find a lot of different pre-trained models online, and the place that you should probably look for pre-trained models is called Hugging Face. So Hugging Face is a website that contains pre-trained model, not only for Pegasus, but also for other transformer models. There you can find, for example, the Pegasus-large model, etc. So similar stuff. I've decided to use the Pegasus XSum model for the purposes of demonstration. Now, once I pick the model, I can go ahead and create my tokenizer. So I'll use what I've imported earlier, the Pegasus tokenizer, and I'm going to say from pre-train. Now, if I didn't have already downloaded the model that I've chosen above, I would need to download the model and this would last a little bit longer. However, since I already did that, I can just reference the model name and I can load my pre-trained tokenizer. Once I load in my pre-trained tokenizer, I can use it to tokenize my text. Now, why is this important? Well, models, transformers, and other deep learning models can't actually take in text as input data. They can only take in numbers. So what do we actually do when we have text and we want to operate on that text? Well, we use a tokenizer. This tokenizer will create numerical representations for our text, for our words in our text. And then we can use those numerical representations. We can use those numerical representations to actually operate with our model, so to use them alongside our model. Now that I've loaded in my pre-trained tokenizer, I can also load in my pre-trained model. Again, I'm just going to say Pegasus for conditional generation from pre-trained, and I'm going to reference my model name. And I'm going to store the result inside the Pegasus underscore model. Now that I've loaded both the tokenizer and the model itself, I can actually tokenize my data. Which means that I'm going to take the example text that we've defined when we were working with the text rank algorithm. So I'm going to take that example text and I'm going to tokenize it using the Pegasus tokenizer I've defined earlier. Now, if the text is too long, we usually truncate the text. And if the text is too short, we usually pad the text to make sure that all of the inputs are of the same length. So because we're inputting, let's say, sentences, we want all of our inputs to be of the same length. So we don't want to have one input that's of length, let's say 50, and another input that's of length, let's say 25. So we just take a look at what is the longest input we have, and we pad all of the other inputs to be the same size of the longest input. Of course, there is a maximum size. So because of that, we truncate to the maximum size the model will take in. In this case, we're nowhere near the maximum size because we're using a small article as an example text. However, this is important to know when you're working with larger amounts of text. Of course, since I'm working with PyTorch, I'm also going to return PyTorch tensors. If I were working with TensorFlow, so another framework, I will return TensorFlow tensors. So this is purely a matter of preference, depends on what you are using. Now, once I tokenize my data, I'm going to get tokens that look like this. So essentially, I've got some tensors, I've got some tokens, and I've got an attention mask. Now, we're not going to dive deep into what an attention mask is or what attention at all is, because that's something that's deeply connected to transformers. Again, if you want to know more about it, take a look at our article. But for now, it's only important to take a look at the tokens themselves. So these are tokens that represent different parts of our input text data. Now that we have those tokens, what we can actually do is we can get our summary. So we're going to reference our Pegasus model that we've defined earlier, and we're going to say generate, and we will unpack our tokens. This way, we're going to get an encoded summary. Now, what does that actually mean? Well, this is the part where we actually summarize our text. So we are putting in some tokens that we have in our original input document. The Pegasus model is taking a look at them, and it's doing its thing. So it's a transformer model. It's doing what transformer models usually do. Again, take a look at our article if you want to know more about transformer models, and it's giving us an encoded summary. Now we say that the encoded, we call it an encoded summary because that summary is again in the form of tokens. Models work only with numbers, they don't work with words. So if we want to get words from those tokens, we need to decode the summary. We need to decode our original encoded summary. Again, we can use the tokenizer for that because it knows how to transform tokens into words, and again, transform words into tokens. And we can reference our encoded summary. Again, we can skip special tokens. This is something that's not important, not particularly important, just leave it at true. And we'll get our decoded summary. Now, this decoded summary looks like this. So it says deep learning is a branch of computer science that deals with the study and training of machine learning. As you can see, we've got a summary, but this summary is pretty short. What if we want a summary that's a bit longer, and what if we want, let's say, more control over the summary that we're getting? Well, there's also a simpler way to summarize data using transformers, and that is to import pipeline. Now, once we've imported a pipeline, we can create a summarization pipeline. To create a summarization pipeline, we define the pipeline function, and then we say that we want to perform summarization. We choose the model we plan on using, which is the Pegasus XSum model. Then we choose the tokenizer we plan on using, which is the Pegasus tokenizer that I've defined before, so the pre-trained tokenizer. And again, we define the framework, which is in this case PyTorch. I could have, as I mentioned before, I could have defined TensorFlow. It depends on what you're currently working with. So I'm going to define this summarization pipeline. And once I have this summarization pipeline defined, it actually goes through the same steps that I've gone through a few moments ago. So it will create a model, it will create a tokenizer that we can use. And now that we have our summarization pipeline, we can just, and that we've stored inside of the summarizer variable, we can input some example text, and then we can input two other arguments, minimum length and maximum length. And this gives us the minimum length of our summary and the maximum length of our summary, which allows us a lot of control over how big our summary is going to be. So if we have, let's say, something like an article of 100 sentences, we can say that we want something that's the maximum length of, let's say, 20 sentences or something like that. Now, do take into consideration that this does not represent the number of sentences, but actually represents the number of the tokens we have in our particular summary. So if I run this, I'm going to create a summary. It seems like it's finished. And now we actually have our summary. So if we take a look at our original text, so this is our original text, and we can compare it with our summary. So all of this is our input document, and this is the summary that we got using our summarization pipeline. So as you can see, it doesn't mean that this summarization pipeline won't necessarily have parts that are the same, or that it won't get something wrong. For example, as you can see, the summarization pipeline made a typo here. But most of the time, it will create sentences that are unique. For example, this sentence right here, or this sentence right here. So it will create unique sentences, or to be more specific, it will create abstractive summaries. This is more or less it. To summarize, no pun intended, in this video we covered automatic text summarization. We explained what it is as a process of condensing a larger text document into a smaller text document using some computer algorithm or machine learning model. We explained how different companies can use it, and we also explained how you can separate different methods into extractive methods and abstractive methods. We also then explained how the text rank algorithm as an extractive method works, and how the Pegasus transformer model as an abstractive method works. If you found this video useful, click on the like button below, and if you want to see more videos like this one, please subscribe.